Oh, sorry, I'm not able to be in class today. I'm not feeling the best. I thought I would give you a couple example problems, this being one of them. Both of these example problems go along with the work that's on worksheet C.3.3, and so use them as you need. So in this problem here, excuse me, we're converting, or we're saying, suppose that 32.5 kilojoules of energy were transferred to 405 grams of a solid water at negative 80 degrees Celsius. That's kind of cold. What would the final temperature of this water be? Well, I've got all these constants here, and we'll point out which one we need here in just a second. But the first thing I want to do is I want to sketch a temperature versus time graph. And so I'm going to come over here, and I'm going to sketch my y and my x-axis. And then on the y, I'm going to put capital T for temperature, and then on the bottom, I'm going to put capital E for energy. Or you could put lowercase t for time, either or. And so in this case here, what we're looking at is we're starting at negative 80 degrees Celsius. And so I've got this liquid water, or excuse me, the solid water at negative 80 degrees Celsius. And I'm pumping energy in. So the question is that going to cause the temperature to go down or up? Well, if I'm pumping energy in, that's going to cause it to go up. I just don't know to what temperature. So I'm just going to come up here, put a question mark there, because I don't know what that is. And I know it's going to be a line like that. The key thing is to see that is because that is a diagonal, and diagonals always follow the following equation. Q is equal to mc delta T, which is mass times the heat capacity times the change in temperature. And so if I were to ask myself, okay, what is Q? Well, Q is the amount of energy that's either being added or removed from the system. In this case, we know how much energy was added to the system. It's 32.5 kilojoules. So I'm going to say, okay, 32.5 kilojoules is equal to, now do I know my mass? Well, let's see. Suppose that 32.5 kilojoules of energy were transferred to 405 grams. So that is my mass. I'll put that in parentheses here. 405 grams. And then I've got my C, which is my heat capacity. Now the question here, these are constants that are given. They're at the top of your page. Of these constants, which one do I want? Well, I know that I want C, or heat capacity. The question is, do I want heat capacity for a liquid water, heat capacity for solid water? In this case, it's pretty obvious. I'm dealing with something that's below 0 degrees Celsius, and so I want the solid water constant, the 2.1. So I'm going to plug that in right here. 2.1 joules over grams times Celsius degrees. Close my parentheses. And then delta T. Well, delta T, that delta means change in temperature. I know what my temperature starts with, it's a negative 80, but I do not know how much it changed. So I'm just going to leave that as delta T. Or if you are more algebraic in mind, call that X. And so now the question is, how do I solve for this? Well, there's one thing that you need to notice on this problem. There's a little bit of a problem. If I were just to solve for delta T, I'm going to get a really weird looking number, because I'm talking about kilojoules here, and I'm talking about joules over here. So I need to change these kilojoules to joules. And the way that I do that is I simply move the decimal. Now, I'm going to move the decimal 3 spots this way. 1, 2, 3. So that would be 32,500 joules is equal to, and then I'm going to go ahead and multiply those guys. So I'm going to calculator out. 405 times 2.1 is 850.5. Now I know the temptation is just to ignore units. However, I would strongly urge against that, because checking units is a way of checking whether you are correct or not. When I multiply grams times something over grams, the grams will cancel. So therefore I'm left with joules over Celsius degrees. Joules over Celsius degree. And then I'm multiplying that times delta T, or X. So now the question becomes, what do I need to do to get delta T all by itself? Well, I'm going to divide both sides. Because I'm multiplying these guys, I'm going to divide it. Opposite in operation, 850.5 joules over Celsius degrees. And then I'm going to do the same thing over here. 850.5 joules over Celsius degrees. These will cancel. And look here, my joules cancel because I'm dividing them. And because that's in the denominator of the denominator, that Celsius actually pops up into the numerator. And so when I do that, 32,500 divided by 850.5, I get 38.2. I'll worry about sig figs later. And that's equal to my change in temperature. And so, let's talk through this. Is that my final answer? The answer is no, it's not. Because it's wanting to know the final temperature. So if I started at negative 80 degrees and I change my temperature by a positive 38.2, well then all I need to do is add them together. And so therefore I'm going to take negative 80, I'm going to add the 38.2, and so that's going to leave me at negative, and I should have 3 sig figs in this, and so I'm going to go 3. That should be negative 41.8 Celsius degrees as my final temperature, and that's my final answer. That's a problem very similar to the one, a couple of them that you work on your worksheet.